Hi guys, welcome back to my YouTube channel. Today we want to take a look at operation of surds. So before that, let's take a look at some explanations on this. So we have it to be if some numbers can be expressed as ratio, e.g. we have A divided by B. Now, where A and B belong to a set of integers and B does not equal 0, such numbers are called rational numbers. Now, examples of rational numbers are 3, 2 over 5, 3 over 2, 2.7, and etc. So other numbers, however, cannot be expressed as a ratio of integers. Such numbers are called irrational numbers. They are irrational because their exact values are not determinable. Only the approximate values can be known. E.g., we have pi, we have exponential, and etc. Now, definition of surds. Surds are irrational numbers. They are the roots of rational numbers whose values cannot be expressed as exact fraction. Take note of that. Now, examples of surds are square root of 2, square root of 7, square root of 12, square root of 18, and etc. So now let's take a look at rules of surds. So let's say we have rule 1. The rule 1 says that when you have square root of p multiplied by q, this can be expressed as square root of p multiplied by square root of q. Now, let's take a look at rule 2. Rule 2 says, we have rule 2. The rule 2 says, when you have square root of p divided by q, this can be simplified to be equals square root of p divided by square root of q. So now let's take a look at rule 3. We have rule 3. The rule 3 says that when you have square root of p plus q does not equal to when you have square root of p plus square root of q. You need to take note of this. These expressions are not the same. Now let's say we have rule 4. Rule 4 says when you have square root of p minus q, this does not equal to square root of p minus square root of q. And that is rule 4. So take note of this, that provided both p and q are positive, So now let's say we have e.g. when we have square root of 12, we know that 4 multiplied by 3 equals 12. So we can have it back as 4 multiplied by 3. Now by applying the rule 1 that we have above, that says when you have square root of pq equals square root of p multiplied by square root of q. So we can have this to be equals square root of 4 multiplied by square root of 3. Or when you have 6 multiplied by 2 equals 12, then we can have this to be equals square root of 6 multiplied by 2, which equals square root of 6 multiplied by square root of 2. Also, when you have square root of 7 divided by 2, this can be expressed as square root of 7 by applying the second rule that says when you have square root of p divided by q, this equivalent to square root of p divided by square root of q. So by applying it here, we have it to be square root of 7 divided by square root of 2. Also, let's take note that students should avoid the error of writing square root of p plus q as square root of p plus square root of q. Or when you have square root of p minus q as square root of p minus square root of q. As these are wrong methods of evaluation. So students to take notes should avoid the error of writing square root of p plus q as square root of p plus square root of q and square root of p minus q as square root of p minus square root of q, as these are wrong methods of evaluation. So now let's take a look at basic form of surds. So before that, let's take a look at explanation of basic form of surds. So we have it to be if p is said to be in its basic form if p does not have a factor that is a perfect square, though square root of p will only be basic if square root of p cannot be broken down further into two factors where one of them has an exact square root, e.g. square root of 6, square root of 5, square root of 7, square root of 2, square root of 3 are in basic form. Here where we have square root of 18 it's not in basic form because it can be broken down into square root of 9 multiplied by 2. And that's why we say if square root of p is said to be in its basic form if p does not have a factor that is a perfect square, though square root of p will only be basic if square root of p cannot be broken down further into two factors where one of them has an exact square root. Get it right? So we have square root of 6, square root of 5, square root of 7, square root of 2, square root of 3 are in basic form, because they don't have a perfect square. Here that we have square root of 18 is not in basic form because it can be broken down into square root of 9 multiplied by 2. And take note that square root of 18 that equals square root of 9 multiplied by 2. 9, we can have this to be square root of, take note that we can have this to be equals square root of 9 multiplied by square root of 2. So square root of 9 is 3 multiplied by square root of 2. That's why we have it to be 3 root 2. But here 3 root 2 is now in basic form because we believe that there's no perfect square for root 2. And that is the definition for basic forms of surds. Now let's take a look at more examples under basic forms of surds. When we have square root of 3, it's in basic form. When we have square root of 2, it's in basic form. When we have 3 root 7, it's in basic form. When we have root 7, it's in basic form. When we have square root of 5, it's in basic form. When we have square root of 6, it's in basic form, etc. Now let's take a look at similar surds. Similar surds. Surds are similar if their irrational parts contain the same numerals, e.g., when we have 3 square root of n and 5 square root of n. So square root of n and square root of n in these two surds are numerals, are irrational parts, and they have the same numerals, which is n. So therefore, these two surds are similar. We have 3 root n, we have 5 root n. So far that the irrational part of it, which is root n, are the same in both, therefore they are similar surds. In this second one again, we have 6 square root of x and 3 square root of x. So far they have square root of x, square root of x, which is a rational number. So, and they are the same. So therefore, these are similar. 6 square root of x and 3 square root of x are similar because their irrational parts, which is square root of x, are the same. Let's take a look at example 3. We have 5 square root of 2 and 7 square root of 2. The irrational part there is square root of 2, and they are the same in both, so therefore they are similar. They are the same. Note that the following must not be mistakenly taken to be similar. That is, the first one where you have 6 square root of 3 and 4 square root of n. The irrational part of these two surds are not the same, which is for the first one we have square root of 3 does not equal to square root of n. The irrational parts are not the same, so they are not similar. We have 5 square root of 2 and 2 square root of 5. So in this case, the rational parts, which are square root of 2 and square root of 5, are not the same. So they are not similar. We should not be mistakenly taking these to be similar. Now let's take a look at conjugate surds. Before that, let's take a look at some definitions under this. We have it to be conjugate surds are two surds whose product results in a rational number. In an expression containing difference of 2 square, it is known that when we have the open bracket x plus y close bracket multiplied by open bracket x minus y close bracket, we can have this to be equals x squared minus y squared. In the same similar manner, when you have square root of x plus square root of y, so this simply means that we have x to be equals square root of x, we have y to be equals square root of y, and by substituting these in the above, we are going to have a square root of x plus square root of y multiplied by square root of x minus square root of y, which equivalent to square root of x raised to power 2 minus square root of y raised to power 2. And we believe that square root and square, they are vice versa and they will cancel out. So we have x minus y. So let's take a look at examples of conjugate surds. We have one, the conjugate of 3 minus the square root of 3 minus square root of 5 equals square root of 3 by changing minus to plus, and that is the conjugate of this. We have it to be square root of 3 plus square root of 5. 2. The conjugates of square root of square root of 2 plus square root of 3 will be equal square root of 2 then minus square root of 3. So the third one, the conjugate of minus 2 square root of 7 plus square root of 3 will be equals minus square root of 7. Now change the plus here to be minus, will be minus square root of 3, and that is the conjugate of this. So now let's move to simplification of surds. Simplification of surds. Now, surds can be simplified either in their simplest form or as a single surd. Now let's take a look at some examples under this. We have A to be 45. We want to simplify square root of 45. We have B to be square root of 98. Then we have it to be solution. We have 45. But note that 45 can be simplified to be equals 9 multiplied by 5. Now let's substitute it here. We have it to be square root of 9 multiplied by 5. So we can have this to be equal square root of 9 by we have square root of 5. Note that square root of 9 equals 3 because it is a perfect square. So we have this to be equals 3 multiplied by square root of 5, and this equivalent to 3 roots 5. So it is now in basic form. So the second one, square root of 98. Square root of 98. Note that 98 can be simplified to be equals 49 multiplied by 2. So now let's substitute it here. We can now have it to be square root of 49 multiplied by 2. Square root of 49 multiplied by 2. And this will be equals square root of 49 multiplied by square root of 2. Note that 49 is a perfect square because we can have it to be 7 multiplied by 7 equals 7 square. So square root of 49 equals 7. So now we have it to be 7 multiplied by square root of 2, which equivalent to 7 roots 2. So now let's take a look at addition and subtraction of surds. Addition and subtraction of surds. So we have only surds in the same basic form can either be added or subtracted. Take notes. Sometimes there may be a need to simplify such surds before doing either the addition or the subtraction. That is, before you can say you want to add or subtract any surd, they must be in their basic form. Evaluation. To question 6, let's take a look at examples. Question 6, evaluate square root of 32 plus 3 square root of 8. So from here, we can now have it to be square root as a solution. Have square root of 32 plus square root 3 square root of 8. Note that 32 equals 16 multiplied by 2 and 8 equals 4 multiplied by 2. And again note that 16 and 4 are perfect square. So let's substitute this here. We have 16 multiplied by 2 plus 3 square root of 4 multiplied by 2. Now let's simplify this very well. Now we have this. The first one will be square root of 16 multiplied by square root of 2 plus 3 multiplied by square root of 4 multiplied by square root of 2. Square root of 16 will be 4 because it's a perfect square multiplied by square root of 2 plus 3 multiplied by 4 square root of multiplied by 2, sorry, square root of 4 equals 2, square root of 16 equals 4 because they are all perfect square. So we have this to be equals 3 multiplied by 2 multiplied by square root of 2. Square root of 2 and square root of 2 are not perfect square. So we have 4 root 2 and 3 multiplied by 2, 6. We have 6 root 2. So so far they are the same. The rational parts are the same, are similar. So we can add them together by taking their coefficients. By taking their coefficients, the coefficient of the first one is the square root square root of 2 there is 4 plus the second one is 6, then taking the only one irrational part, which is square root of 2, so we have it to be 10. 4 plus 6 will be 10 square root of 2. Bye.